All right, guys. Today's notes are over Chapter 2, Section 6. And these are specifically going to be proofs where we're proving angles to be congruent. So for these notes, I'm going to go ahead and say this. You don't really need to copy any of this down. The first few definitions here and theorems, you might want to copy down because they are good things to have, but these are all review. So we have talked about all these before, but if you want to copy down these first 6 definitions / theorems to have them, that might be a good idea, but the proof that I'm doing, you don't need a copy. Okay, so for your notes today, when you're watching this video, just worry about the first part. So, again, these first 4 definitions here are things we've talked about before, but just to kind of remind us. The definition of congruent angles tells us that if, for example, angle 1 is congruent to angle 3, then we can say the measure of angle 1 is going to equal the measure of angle 3, and it also works vice versa. The measures are equal, then the angles are congruent. Okay? Definition of supplementary. Basically, if angle A and B are supplementary, then we know that their measures, so the measure of angle BA plus the measure of angle B is going to be 180. Okay? And going off of that, definition of complementary would tell us, okay, if we have angle A and angle B and they're complementary, then the measure of angle A plus the measure of angle B would be 90. Okay? Next definition, before we get into our 2 theorems here, says the definition of a right angle would basically tell us if angle Y is a right angle, then we can say the measure of angle Y is 90. Okay, so those are just some kind of refreshers on definitions and what exactly they mean in context. So now we're going to look at a couple theorems to remind ourselves of. One of them is the linear pairs theorem, which is a very important one that you need to always remember. And the linear pairs theorem tells us that if angles form a linear pair, then they are supplementary. And then last theorem says the right angle congruent theorem. This we haven't really specifically talked about, but it makes sense. Basically, the right angles congruent theorem tells us that all right angles are congruent because all 90-degree angles are going to equal each other. All right, so now I'm going to walk you through a proof where we're going to prove a couple angles congruent. Again, you don't need to copy this down because we're going to do more examples in class when I see you in person, but I just want to show you one to give you an idea. So here, we are specifically given that angle 1 and 3 are vertical angles. So if you look to this picture here, angle 1 and 3 are definitely vertical angles. And we're trying to prove then that the 2 of them are congruent. All right, so we're going to do that using linear pairs. But first, remember, all proofs have to start with your given. So I'm going to start by writing my given, which is that angle 1 and angle 3 are vertical angles. And again, my reason is that that is given. Okay. Now, I'm going to basically go from there. So, if 1 and 2 are next to each other and 2 and 3 are next to each other, we know also that they're linear pairs. Okay? If they're linear pairs, then they're supplementary. So I'm going to go ahead and say that I know that angle 1 and 2 are supplementary. and so are angle 2 and angle 3. Because they're linear pairs. If you look at the picture, you can see that they are linear pairs because they're right next to each other forming a straight line. So our reason would be linear pairs theorem. Because as we talked about above here, linear pairs say that linear pair theorem say that angles that form a linear pair have to be supplementary. So since we know 1 and 2 and 2 and 3 are linear pairs, they're going to be supplementary. The next thing we want to do is we want to deal with what it means to be supplementary. So we talked about in proofs that every single vocab word you see has to be defined. Okay, so every time you see something like supplementary, you got to tell me what that means. So basically, it means that the measure of angle 1 plus the measure of angle 2 is 180, because that's what we know from up here. It means to be supplementary. Their measures add up to 180. And so are the measures of angle 2 plus the measure of angle 3 is going to be 180. And that's just from the definition of supplementary. Okay. This next part works kind of cool. So notice both of these equations here are set equal to this 180, right? So the measure of angle 1 plus the measure of angle 2 is 180, and the measure of angle 2 plus the measure of angle 3 is 180. That means that these two have to be equivalent. They have to be equal because they both equal 180. So that means when you add them together, you're going to get 180. So these two are both going to equal each other since they both equal 180. So we can say that the measure of angle 1 plus the measure of angle 2 equals the measure of angle 2 plus the measure of angle 3. The reason that works is because we're using substitution. So you're basically substituting in the measure of angle 2 plus the measure of angle 3 for this 180, right? Because we said it equals 180, so you can substitute that in. So we are using the substitution property to do that. Okay, so now we have the measure of angle 1 plus the measure of angle 2, and the measure of angle 2 plus the measure of angle 3. Notice measure of angle 2 shows up in both places, which means we can get rid of that measure of angle 2, which is good because we don't even want it. We're trying to prove that 1 and 3 are congruent. We don't even need the measure of angle 2, so we want to try to get rid of it. Well, if you have it on both sides, you can just subtract it from both sides. So if we subtract the measure of angle 2 from this side, you just have the measure of angle 1, because it would be 0. And then if you subtract it from this side as well, once again, it would become 0. They would cancel, so you just have the measure of angle 3. And that's from the subtraction property, because we subtracted the measure of angle 2 from both sides. Now, last but not least, since we say the measure of angle 1 now equals the measure of angle 3, we can say that means they have to be congruent. That's straight from up here. If their measures are equal, then they have to be congruent, which is good because that's what we were trying to prove. So the reason why is because of the definition of congruent angles. So that's an idea of a proof that shows you how to prove that specific angles are congruent. We're going to do more of these in class, okay, and you're going to get more practice because the more practice, the better you get. But what's cool about what we just proved is we just proved the vertical angle theorem. And that tells you that vertical angles are congruent. Now that we have proved that, we can use that to help us in the future. So we know vertical angles are always congruent. All right, that's all for this video, guys. I'll see you next time in your class. Have a great day. Bye.